Okay, folks, so we're going to try and record the lecture this time. I tried last time, but when I opened up the file, the MP4 was 3 seconds long. So I didn't upload that to YouTube. You should be able to now see on Canvas. I put a bunch of stuff. Anyone not been able to access Canvas? Okay. Everyone has filled out the student help session spring 2024. Has everyone able to see the Slack messages? And you're not ignoring me, right? You're just very busy reading ahead of time, right? Right. Not doing anything else. Not having a personal life, right? Not enjoying yourself on Sunday, watching your two favorite teams win. Okay. So here's where we're going to start today. And don't do this right now. You can do this. I mean, obviously we have a large lab time. I dropped this in the Slack chat so you can find it there. If you can't find the Slack or you're not in it, let me know and we can resolve that when we get into the lab part of lecture. Let's go to the right tab. We saw this just because, I want to just clarify for anyone who wasn't able to make it to the first lecture. And since my recording didn't recorded, I can walk you through the entire syllabus, but we'll just talk about what we're doing today. And that is we will start with an in-class presentation, and then we will do example problems together, right? As we always do. And from that learning experience, we will develop our skills that'll send us towards the homework. You can work on the homework together. I have no problem with that, but you can't copy one another's code without giving due credit. So if Bob wrote this piece of code, you say, Bob wrote this. That's why it looks the same in both of ours. We shared this piece of code. But if you share the whole code, the entire homework, I will say, no. That is only one of your homeworks. So decide who gets the credit, right? Okay. This is the content calendar. Interesting. No name is written on today's date, which means one of you will be randomly getting selected to present today. This is why, as someone so rightly pointed out last week, it's better to put your names earlier rather than later. So that way the material is still easier. But I know that you all read the material ahead of time, right? So you're all prepared? Everyone looks down at the computer. Okay, so this is the expectation that I have of you, right? In a class like this, as you move into the upper divisions, there'll be more expected of you. And yes, more is expected of me, but I know this stuff already, right? So I'm not just a fountain of knowledge that I just pour directly the words into your brain. You have to grab the things, right? There's a famous saying, you can't force a horse to drink, you can only bring them to water, right? So if you decide, hey, I don't really care, I'm just happy to get a C, that's fine. Just let me know that ahead of time, okay? But I want to give you all A's. I have no problem giving everyone in this room an A if you put in the work. But part of putting in the work is coming prepared. So if you come and you've never read what we're going to do on the day we do it, you're wasting your own time, because in the lab section, that's where you get to practice it, right? So that's where you're actually going to be writing code. And if you're just learning it for the first time, you've never seen it before, you're going to be like, what the hell am I doing? Right? Like, we're learning a new language. So part of learning that new language is speaking it. Speaking it is the coding part. Learning it ahead of time is going and figuring out what the words are, okay? So we'll have a little bit of a slower introduction into it, and that's why the earlier presentations will be easier. But by the time we get to week 4, we're going to be talking about how to do math. And then you'll be throwing together math that you don't get with computation that you're just learning, right? So I'm telling you ahead of time, it will get harder. Okay? But I'll be here. That's why we're going to do the student help sessions. That's why we're going to have really long time periods to talk about it all. We'll put stuff on the board. We'll talk through it all. Okay. Questions about the format of the class? Okay. Again, only 4 of you introduced yourself. That's okay. I don't even care. I'm not crying about it. Do I practice acting? Not anymore. Hold on. Let's do the oh, I didn't do share screen. I guess you're just seeing my beautiful face. Not anymore. That is something I did when I was younger, but not currently making any money from it. My favorite topic in physics? What is my favorite topic in physics? I guess probability and statistics, but maybe modeling. You know, I think both of them are fun, but data analysis is pretty fun. One thing I enjoy the most in physics, baseball. So you might not think that that's there's a reason why nerds get really attached to baseball, and that is because of all of the 4 major sports games in the US, you know, football, soccer, and basketball. This is one that has the most like quantifiable outcomes. So people build really cool models about performance. And then you have large sample size because it's a really long season. So events happen over and over and over, and you get, you know, a really good sampling of that data. So you can build like wild statistical metrics to understand what's happening over the course of 6 months that are actually, they bear out to be quite true. It's pretty cool. But it's super nerd. I go onto websites that are like, you know, green and white and look like they're made by someone who doesn't have any money, because they don't. But that's like where I spend my time. What's the thing I enjoy doing outside of physics? Nothing. I'm really boring outside of physics. That's all I do is I work here and then I go home and I sleep. I have plants and dogs. And then that's not really a question. Okay. And here's the YouTube channel. At some point there will be these lectures in here. I'm hoping right now this is recording. The link to YouTube is on our Canvas, and our Canvas has all of the, oh, is this the right class? Mod class. So you go into modules. You'll notice that I don't really like Canvas and I don't really put a lot of stuff into it. I just don't like the formatting. I'm sorry. If you have other professors who are better at this, you know, give them a round of applause, because I never got good at this. So I just like stick stuff in here. So the content calendar, you click on it and it takes you to this link, and then you can like go in here and you can edit it. I think there's a link at the, oh, there's no link at the bottom. I'll add the link at the bottom for where you can find it so you can add your own name. Maybe that's why no one added their name, right? Oh, right, of course, of course. It didn't let me, of course, yeah. And then let's go back to the modules. Here's some other ones. So this is linked to YouTube. This is the assignments policy. So this is basically what we talked about on Wednesday. And it's just a description of it. If you have questions about that, we can answer them. And then the ungrading policy that we'll be using for this class. So far, I haven't had any complaints about the policy itself. Right? Okay. And then if you're like, hey, I don't want to talk to you, but I want to give you feedback about how the class is doing, you could do that here too. You can do that anytime. Okay. Questions, comments, concerns before we get into today's content? Okay, so let's look at the content calendar, because this will be scripture for me. We're going to do 2.3, if and when statements. So let's make sure that here's, let's zoom out a little bit. This is the whole book, by the way. You're able to find this book if you haven't bought it already. I recommend buying the book, but if you want a PDF version, it exists. Oh my God. Okay. And we could, of course, take this a little slower, because I don't think we got as far as we wanted to. Maybe we did. Let's have a look. So we got through sections 2.2. I basically described it. We haven't learned about arrays. We're learning about programming now for the first time. Oh my God. There we go. What? 2.2? Yeah. Okay, so this is where we got, right? We got to exercise 2.1, and then we were working on exercise 2.2, which is part of the group work. And this comes from the idea of how we do math. So let's just refresh our memory here. How does this work? What does this mean, this first line?
You know, finding the number 9.812 the letter G's.
Letter G. Is that correct? Letter G? Variable G. Okay, we want to be very specific here. But listen to the words that Alfred used, right? We're assigning. We're not saying equals. We're telling it what G is. Very good. How about this one? What's happening in the second line? Assigning an equation to a variable, okay? So let's break that down a little bit. When we say the equation, we're assigning an equation. Is the value going to change? No, because it will treat G as what? Exactly right. So 9.1. So this will just be fixed. So this will just be a number. S will just be a number, right? Okay, good. Okay, so what we're going to be doing today is talking through 2.3 and 2.4. There will be a little discussion of functions and packages. We'll do this when we get into the first part of actually coding. But let's just move ahead to we said comments, right? We went through that. We like comments. Why do we like comments? Do you remember what you're doing? That's one good reason. What's another one? So other people know what you're doing. Good. What else? So I can know what you're doing. Good. And what else? Most important reason? Comments are 10% of your grade. If I don't see any comments in your code can only ever achieve a 90. Okay? Now the comments have to be meaningful, right? You can't just have a bunch of comments with the description of your day or your shopping list. Your comments have to be meaningful because they have to be part of what we call good coding practices, which we'll get to at the end of probably next week. Okay? All right. So let's go to this part here. Who wants to present if and while? You ready?
Yeah.
Okay, so you're not reading it. So you're going to summarize it, right?
Okay.
And what you're trying to do here is you'll tell me to go up and down. And if you want, you can stand up. You don't have to stand up. But what we're going to be doing is you're going to be talking us through what we're supposed to learn about today. Okay?
So if and while statements, they march from statements to the next, beginning to end, etc. And it's an important feature for computers because they have the ability to break the linear flow of the code. Jump around from program. It executes lines and not others, so it separates. And
Okay, so let's do an example of that, right? Because what he just said was version of something we call a conditional, right? So far, we've seen the first line leads to the second line, leads to the third line, leads to the fourth line. So it's all been linear, like Isaac said, right? And now we're not doing that. So can you describe what happens here for us?
so where x equals the input, and then you put in the value. If x is less than 10, then it's going to print that you entered a value greater than 10. And then if it prints again, let me fix that. If x equals 10, then it's just going to tell us that our number is s.
Okay, yeah. So let's walk through this a little more slowly. Okay. So let's remember in practice, this idea of input for this thing that we did last time, we're not really going to do it when we're doing like adults coding. But right now we're using it as a substitute for understanding how the computer takes information in, processes it, and then does something else. So last time we did something where we said, we're going to drop a ball and we're going to ask how far did it fall? And we're going to find out where its height was above the ground, right? You all did this? And in that process, you drop the ball, you ask the user for an input. And we never ask the question, what happens if you give it like the word apple? Right? So I could have, in that computer program, I could have said, give me an amount of time after the ball has been dropped, and you write the word apple. And the computer would do what? Nothing. It would not know how to deal with it. Conditional statements like the one here prepare the computer to do something based on your input. So to Isaac's point, it says, if x is greater than 10, then do all three of these things, right? And otherwise, what would the computer do if x was equal to or less than 10? So it just would ignore this entire imprinted block. So the one thing that we have to keep in mind in using Python is that the white space, so what I mean by that is, notice that there's an emptiness here. That's called white space. That is actually important to the computer. that tells this section that this inside of the if x greater than 10, all of that stuff tabbed to the right, treat this all as one conditional block that is the result of the colon here. So it says if this thing is true, colon, block. And then since this is outside of that block, this is not inside of this. Does that make sense? So generally speaking, what I will do, I'll make it look prettier. I'll do this line, and then I'll do a new line, an empty space in between, and then this block, and then another empty space. And that way I don't accidentally have x equals 10, just like 1 over here. So I can see in my mind they're separated chunks, right? And we'll practice this when we get into actually writing it. Does that make sense? No one's listening. Good. Okay, continue.
If I run this program and type in 5, you'll get the print, enter a whole number no greater than 10. So it'll just tell you your number is 5.
Good. And that's what we expected? Well, I mean, you're reading from a book, right? So the book's probably right. Okay, what about the other one?
But if I break the rule and enter 11, you entered a number greater than 10. And then it'll fix that for you. And then it'll say your number is 10.
Good. So it's a little sassy computer, right? It says enter a number no greater than 10, and then you enter one that's greater than 10, and it says, let me fix that for you, and it replaces your choice, right? Okay. Okay, keep going.
Enter a whole number no greater than 10. Oh, okay. The behavior is achieved using an if statement. The second line is the program above, which tests the value of the variable x to see that if it is greater than 10. Note the structure of the if statement. There is the if part itself, which consists of a word if, followed by the condition that you were applying. In this case, the condition is that x is greater than 10. The condition is followed by a colon, and following that are one or more lines that tell the computer what to do if the condition is satisfied.
Okay, so hold on. So we're not just going to read the whole thing, right? Let's just summarize. Just hit the find points, right?
So it's in the program, there are 3 of these lines.
You can spend a few seconds summarizing it in your head, yeah. So this is why usually when I have my book, I have my highlighter out. I'm just going to hit it with the highlighter. And remember, this is our first couple tries here. I'm not going to grade you based on the quality of your presentation. I want you simply to engage with the material, right? So doing the presentation is what matters.
Note that these 3 lines are indented. This is how we tell the program which instructions are part of the if. Only if x is greater than 10 in this case, whether or not the condition is met, the computer then moves on to the next line of program.
Good. What does that mean?
It's kind of like this. It's very much trying to set points that they want to hit for your if ones or if while students.
Yeah, right. So in this section here, right, you're saying, okay, this block here, do these 3 things, point 1, point 2, point 3, right? That's a great way of thinking about it. Now we'll have to be a little careful with our words because lists will end up being a thing that we require as well. So will arrays. Language is a fickle mistress. Okay, what else? Anything else with this section?
So here we see an exception to the rule that spaces at the beginning of lines do have an effect with the statement. So we should be careful putting spaces at the beginning of lines. They should only be added when needed, as here and not otherwise.
Right. So normally when we write in our code, you can have as many spaces as you want, like inside of the actual word. So once this line has started, for example, so let's say I write x equals int. If I write the letter x and then I write space equals, I could put like 7 spaces before the equal sign and it won't care. Right. And sometimes you'll want to do that, at least for me. Like let's say I have a bunch of variables and I write them all out. And one of them is like cat, but one of them is hippopotamus. Right. But I want all the equal signs to line up. So then I can have a whole bunch of space missing in the, it's cat space equal, so that all the equal signs line up, just so it looks pretty, right? Just for me personally. Some people with OCD might need it, but I just like it, right? Make sense? Questions, comments, concerns? Okay. Good. So here's a set of conditionals. Right? Want to break these conditionals down for us, Isaac?
So if x equals 1, check if x equals 1, note double equal signs. If x is greater than 1, check if x is greater than 1. If x is greater than or equal to 1, check if it's greater than or equal to 1. If x is less than 1, check if it's less than 1. If x is less than or equal to 1, it's less than or equal to 1. Exactly.
Yeah.
And then check if x exclamation is equal to 1. Check if x is not equal to 1.
Good. Okay, so these are very specific terms that the computer knows. So if we break these down, right? What does equal mean in algebra? When you're writing this for your, mathematical methods class or your vector calculus class, you write equal. If I write this and I turn it into my professor in my vector calculus class, what are they going to say? What are you doing? You crazy? I could do something like this, x is defined as 7. All right, 3 of them like that, but there's no button like that on my keyboard, at least on the standard keyboards. Okay. So instead, this double equal sign is check whether this is true. As opposed to this, which is you're telling it, we're assigning it. We call this assignment operator. Okay. Cool. Okay, so these ones are straightforward. Greater than, less than, alligator. We know the alligator ones. Alligator eats the bigger one. X is greater than 1. X is less than 1. Okay, X is greater than equal. Okay, we just always put the equal on the right-hand side if we're making a conditional statement. What about this one here? It's the not operator. Okay. So this means no. Okay. Because there's no slash through the equal sign, right? So in this particular circumstance, when we're writing all these languages out, that you'll have to double check them, right? Sometimes you'll put them in the wrong order, and that's perfectly okay, right? And then it'll yell at you and say, I don't know this operation. But generally speaking, when you have an if statement like this, okay, you are looking at 2 relationships. Okay, so what this is going to do is it's treating whatever this box is. Remember, we had this idea of multiple boxes. And it's going to say, is this box the same as this box? Is this box X the same as this box? 1. Let's say inside of X, I store the word apple. So what is this going to give us? If X equal 1. Nothing happens. And if I just said, X equal 1, let's say I type that in your computer. No, if we have our computers open to code calc. So type the word X equals apple in quotations. And remember, we have code calc open. We're not just opening Google, right? Everyone's clicking away. What's that?
The X is
So let's first start by saying X equals in quotations, the word apple. Okay, and then on the line afterwards, we're gonna write x equal 1. False. What does that mean? I mean, it's not true, right? So there are two conditionals that you'll find in life, in computer life. True and false, okay? Computer does not know maybe. Things either are or they're not, right? Just like we were talking about before, when we store things in memory, we store them as zeros or ones. So you either have true or false, 0 or 1. And it just so happens that that true you get back or the false you get back, is that capitalized? No. Okay. But it's a command. Okay. And so what you can see here is that this is saying if something is true, then do this other thing. So let's go up and we'll look at it. Okay. So inside of the if statement is the following. Okay. If this argument is a true argument, then do this thing. Otherwise, ignore it. Do you see that? Enter a whole number no greater than 10. I enter 5. It holds on to 5. It looks, is 5 greater than 10? Is 5 greater than 10? So what does the computer say? 5 greater than 10 says what? Which of the two statements that I can give? False. So now it says if false, so it doesn't do any of these and it simply prints the number. Okay. So now if I give it the number 11, it says if 11 greater than 10, and that is a true state. So now it operates the if block. Okay. A lot of words, right? We're learning how to think like a computer though. Because unfortunately, we have to take our brains, which are very sophisticated, and we have to make rocks think. You are holding in front of you rocks. Okay? They're very sophisticated rocks, but they cannot think. They don't know what they're doing. So we have to teach the rocks how to think. Okay? All right. We're gonna run a little low on time here, Isaac. So I'm just gonna walk us through the bottom of this. Here's some examples of stuff that we'll do. There's if, and there's this catch argument, which is else. So what that means is that if you have an if statement, you can have it just do nothing, or you can have it say, if the ifs didn't work, catch it with else, right? So if x is greater than 10, print your number is greater than 10, else you can print your number is fine. And the reason that you might want to do that is you might have a number of conditional statements. So what I mean by that is if x is greater than 10, print your number is greater than 10. If stands for else if. Okay. This is going to check after the condition if whether or not this happened. And Python will get really cranky about this. So you can never start with elif. You have to start with if. And you can never put an elif after an else. It's just the structure, right? If any number of elifs you want and an else. But if you start with if, you don't have to put anything else afterwards. Okay? And also, if you really want, you only want to do one thing, you don't want to block, you can always do if, and you can put this right on the same line. It doesn't care. Okay. For us, put it into a block just to like help our brains see the difference in the parts here. Okay. So here's our if statements. And then we have a while statement. Ooh. Oh my gosh. All right. So this is the complicated one that I'm going to walk you through very quickly. And then you're going to be confused. And then you're going to use it. And you're like, oh, I'm so unconfused. Okay. So while basically means that what's happening here is you have some input, okay? And it's going to iterate. It's going to run over and over and over and over until a condition is either true or not true. And in particular, it's looking for what type of condition here? What's that?
If X is greater than 10.
Yeah, so it says specifically, the while statement checks if the condition is met. Okay? If the condition is met, it executes the indented block. If not, it skips the block. So let's think of some reasons why we could ever possibly want to do something over and over and over until we get the right answer. Let's assume it's a password checker. You have the password Jigglypuff, okay? And you go to write it and you miss the Y, right? So it compares the two and it doesn't let you go to the next screen until the two match. It'll just re-prompt you for enter your password, right? This is a while statement in action. While these two conditions are not true or true, depending on how you want to write the statement itself, just keep feeding the person the same input, or you're the person, right? Sometimes the function. I'm going to sort of draw a very small distinction between the computer and you, because you are going to be the computer for all intents and purposes, okay? So let's look at this one here. Enter a whole number no greater than 10. So we enter in a number 11. So let's see what happens. While X is greater than 10. So what is this statement mean?
Greater than 10.
Yeah, but what did I just say? I said X was what number?
No,
No, but what number did I gave an example. Okay, let's put in 11. Okay, let's do them in order. And we'll see what actually happens. So X is 11. So this part is,
Not true. Oh, yeah, true, it's true.
this part is true. So 11 is greater than 10. So while true, what happens? So it says, while the statement is given, in this case, if X is greater than, it executes the block. Okay, so while X is greater than 10, true, it does this. Print, this is greater than 10, please try again, and then asks you to re-input the number. Now notice you have an opportunity here to change X. Let's say you didn't do that. Let's say you accidentally tabbed this to the left. What would happen? Well, would X ever get updated?
Mhm.
No. So what would happen in the computer?
It continues, greater than 10.
Yeah, forever. This is a very easy way to run out of memory and crash your computer. Okay? So while I'm going to teach you how to destroy your computer on the first day or second day, we'll also teach you the rules, so that you don't break it. Okay? So here what you're going to do, you're going to be really sure that this letter that you're checking against is updated in the while loop. Because otherwise the while will never start or never stop, right? Okay. Does that make sense? And this is why putting spaces between your tab blocks, super important. Okay. And then once X is finally less than 10, what happens? Yeah, that's it, right? Okay. In my book, it's highlighted. If it's never false, the loop goes on forever. So this is the reason why we don't always want to use while loops. You'll notice this is an iterable command. Iterable. What I mean by that is that there are iterations. And you'll notice as we start to do computation, there are reasons why we would want to have things that are iterable. So let's say you start by throwing a ball. Okay. You might want to take 1 second steps. And every second you increase the time counter and you figure out all the physics of the ball moving through the air. Right? And then you find the forces at every location and its subsequent position and velocity, right? And you move it forward through the air. There's 2 ways to do that. We'll talk about a while loop right now, and then we'll talk about a for loop later on. And we're going to learn both of these tools. Some of them are useful in some contexts, and some of them are useful in other contexts, okay? Any questions about this part? It's really important to understand break and continue. Okay, this is how you stop infinite loops. Okay, so let's say you have while x is greater than 10. You can have this two ways. Okay, this will continue looping until you enter a number not greater than 10, just like the other one did, except if you enter the number 111. So the word break says, take whatever conditional loop I'm in and exit. And this is wonderful because let's say you're looking for something specific, right? Maybe you're not matching passwords, but maybe, let's see. Maybe you just want time to get to some location, right? And time is increasing here, blah, 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 blah. But you also don't want it to take too much physical time, right? So you say, well, don't run for more than 1,000 iterations. And so you can say, if the iterations become greater than 1,000, just stop. I want to see what actually happened, right? So the break statement lets you exit that interior program. Now you will then continue on in the program. So, you might need other types of statements in there. I tend to use the last name of one of my friends, and I never assign it a variable so that my computer always just gets upset and stops. Says, I don't know what this thing is. But I can always use that as a marker. There's probably a smarter way to do it. I don't care. Okay. And then finally, where's the continue statement? Hello. Where'd it go? Oh, I guess maybe they don't have an example of the continue statement. Continue statement uses rarely in practice. Continue statement just lets you do one more loop. That weird. Just checks it one more time at the beginning. Okay. Break immediately pops you out. Then you're going to use break. Okay. How are we feeling? New tool? Completely lost? Okay. Oops, you don't want that. That doesn't mean anything to you. Let's do an example. Pair programming. So we're going to pull out, where's exercise 2.4? Oh, God. There we go. All right. So this is before we use the if and when statements. This is just getting our brains working again from the very first time that we did this. And if you didn't do this the first time, that's totally okay. I would recommend pairing up with someone who is here. So what we're going to do is we're going to do paired exercises. One of you is the navigator. One of you is the driver. Driver is the only one touching the keyboard. Navigator is telling the driver what to do. And then you work collaboratively to solve the problem. So we're going to start with this problem here. Spaceship travels from Earth in a straight line. Write a program to ask the user for a value of x and the speed as a fraction of the speed of light c. Then print out the time in years that is perceived by person A in the restroom, the observer on Earth, and B as perceived by a passenger on the ship. In case you want to know where that comes from, let's go back to the example. Did I have the example here? Oh, that's silly. For folks who haven't taken special relativity, let's just write it really quickly. What's the distance equation? With velocity and time. What? So x equals v times t, right? and what happens to time and distances as you're traveling near the speed of light. Yeah. So we're just gonna say something along the lines of gamma is equal to a ratio of the square root of the speed of light. So it's something like this. You seen this before? Okay. So this has really fun properties that if V is small, what is gamma equal to? One. Very good. Is that your, okay, good. Gotta speak up. Okay, and then if V is equal to C? Undefined, or? Yeah, another way of saying undefined would be infinite. Okay, so this has a really cool property. It gets really big, right? As you move towards the speed of light. So this is the idea. It starts at 1, gets larger. So let's write it like this. X equals VT, like this. And then it's not really correct. So this will be the rest frame. And this is not quite correct. We'll call it X prime. What do we want to use? What's that? Well, lengths contract, so that would mean we multiply or we divide gamma. Divide. Because the smallest that X can be is 1, and the largest that it can be is real big. Right? So if I took a fraction here, and I said this is the moving frame, that would be perfectly okay. Right? This is not exactly correct. This is what you're going to learn today. So if you really are interested, take E&M2. And in the last week of E&M2, in the 15th week, you have the coolest lecture of all time, and it's special relativity. Now, I think you also get this in modern, but give you a little preview here. So here's the question, and here's how we break down these problems, okay? First, we have to understand the math. We have to take the words from the math and make an algorithm in our head. So what's the process? And we should be writing this down as we do it, okay? We say we have these different variables. We have X, we have V. Okay, so then it says write a program to ask the user for a value of X. So I'll need something that asks the user, which is you, the driver, right? And then the speed of V is a function of C. Okay, so you need to ask for X and V. Right? And then print out the time in years it will take the ship to reach the destination. Okay. Yes or no? Okay, so whoever you were working with last week, pick a new person. So stand up. Crab walk to someone else. Introduce yourself. Remember, you now have 2 hours and 15 minutes to learn someone else's name, to introduce yourself, to become very good at computering.
You want me to go? Just stand up.
Okay, so let's talk about the Catalan numbers here. We're going to use a while statement. So what's the biggest thing we want to make sure we don't do when using a while statement? Make it so it goes forever. We have to be very careful not to break the computer, okay? So the very first thing we're going to think about is when we structure this, we want to make sure that we're careful, because a while statement can be dangerous. Okay. So now let's read, just with that in the back of our mind, we're going to plan how we're going to attack the problem together. And I'm going to demonstrate how I would attack this problem so that you can kind of learn the same technique. Okay, it says the Catalan numbers Cn are a sequence of integers 1, 1, 2, 5, 14, 42, 132 that play an important role in blah, blah, blah. I don't care. Okay, we don't care about the physical implications. We're just computational physicists today. They are given by C0 equals 1. And afterward, all subsequent C Catalan numbers greater than 1 are given by this formula. Okay? So write a program that prints in increasing order all Catalan numbers less than or equal to 1 billion. Okay. So you know you used to do word problems and you had to find out how many watermelons, blah, blah, blah. Okay. So we need to do the same thing here. We need to convert all of these words into a plan that we then turn into code. So how is our code going to look in our mind? What's the first thing we're going to write at the top of the code? A sequence of numbers or numpy. So your top of your code is almost always going to look the same. It's going to add important functions, logarithms, etc. So I'm going to start with, where's my chalk? Yes. All right. I prefer one chalk. Okay. So you're going to have your imports. That always starts at the top. What else goes up here? Your name, and specifically your name and your navigator. Who is your person that you're working with, right? So the very first thing you write, your example, your name. So you write all of this at the top. Imports, names, and problem. Good. Now what comes next? Yeah, so what do you mean by variables?
We're gonna use feature and loops or.
Yeah, so there's some extra words in there that we don't have to use, thankfully, in Python. But basically, we're going to say, does this thing exist? Remember that we assigned lockers. So we need to start with some starting lockers. Okay? And there's two that I see. Okay? So I see C0. And I see C1. Okay? Now, really, this one is Cn. Okay? So I need to define these things. I need to tell them that they are something. And the reason I need to do that is I need to tell the computer to reserve a certain amount of space and what type of space it is. So usually I'll do something like C0 equals 0.0. And that looks like a funny face, but it's not. That is telling it that it's a float, that it's not a string, that it's not an integer. If you want, you can make it an integer. I don't have a problem with that. But you're going to divide integers, and they won't always be good fractions, and they'll turn into floats anyway. Okay. 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 So now I have this number, and then what's going to happen? So I'm going to write up here. This is where you have declared your variables. Now what do I want to do? What? A what? Assign Cn. Yeah, we'll have to define this, right? So I could start this with this first Catalan number. So the first Catalan number is actually not 0. I lied and no one even caught me. It's 1. Good. And actually, they told you what the first few are. So the first one is actually 1. Okay. You can make them ints or not. And then what? A what? So am I just going to write these all out by hand? No, because computer is computer. right? Computer is extension of body now. And we're gonna train it to do our thinking for us. So what is this program supposed to use? Loops, because we just learned about loops, right? All right. So we're going to use two different types of statements today. We're going to use an if statement and a while statement. Or just one, whatever you want. What's the while statement look like?
Wow.
Good.
See much.
Let's be broader.
Next.
While statement is
True.
true.
Is one.
Okay, so this is the thing that you're going to have to define. And you haven't yet figured out what that is yet. And then you're going to do stuff. Right? And then at the very end, you're going to until the statement is not true. Okay, so you want to be careful with this statement that's true. That's the thing I started off by saying. Don't put, like just increase forever, blah, blah, blah. So whatever you put here, it's your choice. But he says, write a program that increases all Catalan numbers less than or equal to 1 billion. So if I were looking at this, I would use a while statement where the conditional was that the Catalan numbers, whatever CN is less than or equal to 1 billion. And you can write that in scientific notation. So if you want to, right, instead of writing 1 like this, ooh, so many zeros, you write what? 29. And the computer will know that. So this is equivalent to 10 to the 9.
Is the 9 double story?
Yeah, you could do that here, but this is cuter. So this is not actually going to be up there. It's just going to be all in one line. Okay. So that's the way that we write scientific notation here. And we would say something like, okay, while CN is less than 1E9, something like that. Now, should you start with a number that big? No, because if your computer's garbage or your number's garbage, it'll run 1 billion iterations before you even notice. Okay, so usually I'll almost always start with something much more manageable. Okay, I'll say, look, I know the first 5, right? So I'll do something like 1E3. And I'll make sure that it quits. And I might even make sure that it quits by adding in here, inside of the while loop, an if statement, a specific if statement. So if Cn is greater than 1E3, break. Good. So now I've double checked, right? I'm going to be 100% sure. And you're welcome to come up and look at it when I'm done. Sorry. It's good for the, oh, I guess the computer doesn't even fucking see. There we go. This is the recording. I started recording. Okay. And so now you will have done all this stuff. And how do you communicate this to yourself? How do you know what all the billion Catalan numbers are? What do you mean comment it? Sure, but so it does this calculation for you, but how did you find out what the answer was? You have to print it, and you have to print it at each step, right? So after you calculate the new one, make sure that you spit it out because you're about to replace it with the new one, right? So if you get to the very end of the loop and you only print the last one, then you'll just get the last Catalan number. You'll have no idea whether you got all the right ones in between. You should print as you go, yeah. Otherwise, you'll lose all the information because it won't tell you. It won't remember that. Basically, the way that it's going to write is it's just going to overwrite CN every time. Every single time it's going to write over it, right? It's only going to remember the most recent version of CN. Okay. And if and when you fuck this up, because everyone does, and it's totally okay, remember that computers only do what we tell them to do, right? you can always halt the process. So if you ever notice that bar, there's a little bar and it's like usually yellow, sometimes green. If it ever goes red, just terminate, kill the kernel. Okay? And your computer went down. So this is why we don't actually do it on the computer. We do it on a hosted cloud. So if we crash the cloud, it's totally okay. That makes sense? Cool. But don't do it on purpose. Okay. Okay. Break.
Yeah. Yeah.
I thought I heard some say.
Exactly.
A little smarter.
Right. Yeah. Because of these, maybe there's a zero.